Hi, in these sections, we will use the following properties of limits to help us to calculate limits then, okay? So this is the property that we are going to work with then. So first, suppose that C is a constant. So you have to understand that in math, when we talk about a constant, meaning we would like to talk about a number, okay? So to be exact, it should be real number then. Okay. N is positive integers. So in this case, what N is, you could consider that N is equal to 1, 2, 3, 4. Okay, those are positive integers. And the limit of f of x, x approach A, and limit of g of x, x approach A exit. Okay, so both of the limit exit them. Then for the following properties, then. So if we have the limit x approach A of the sum of f of x plus g of x, we could rewrite this into the sum of two limits. If we have f of x minus g of x, then it will be the difference of two limits. If we have a constant multiplied to f of x, then in this case, what we could do, we could actually take out the constant and then just evaluate the limit then of f of x. Okay. A product, then we will have the product of two limits. So the limit x approach A of f of x times the limit x approach A of g of x then. If we have a quotient, then again, we just have the limit x approach A of f of x, then find the limit, then we divide by the limit x approach A of g of x. And in this case, if the limit x approach A of g of x cannot be equal to 0. Okay. And then if we have a function raised to the power of n, then we can evaluate the limit of f of x first, and then raised to the power of n. Okay. So then now if we have a limit x approach A of c, A will be equal to c. So now, first of all, how do we consider this c right here is the functions. So in this case, meaning this is x, okay? Meaning we have a function c, y equal to c, okay? And you will see that if this is the case, the input I have A, okay? Do you see that the output from the left and from the right is equal to c, right? So that's why if you take the limit of a constant, it is equal to the constant. So number 8, if we have the limit x approach A of x, the idea here is we have the function y equal to x, right? So then now you will see that if my input is A, then of course my output will be A, okay? If we have a power functions, so if the function is x to the power of n, then we take the limit as x upon A, then the output that we have will be A to the n. For example, if we have the function like y equal to x to the power 3, for example, like this, then you will see that if the input is A, then of course my output here, it will be A to the power 3, right? So, and then if we have n root of x, then when we take the limit, it will be n root of A. If n is even, we assume that A greater than 0. Okay? Now, if n is even, that means, for example, like square root of x then, right? So you will see that the graph that we have, y equal to square root of x, the graph basically is, the domain is from 0 to infinity. So that's why when n is even, you have to be careful, right? Then A must be greater than 0. Okay. And the property number 11 is just kind of like follow the number 10. So if we take the limit a x approach a of the function n root of f of x, it will be equal to the n root of the limit x approach a of f of x. So, okay. Same thing, you need to be careful when n is even. Then we assume that the limit x approach a of f of x greater than 0. Okay. Then now let's see how we use the limit law to actually to help us to work on example number 1 now. Okay. So right now I have two limits. One is the limit f of x has x approach 2 is equal to 4. And the second is the limit of g of x has x approach 2 is equal to -2. Okay. Okay, so in this case, how do we actually work it out the problems? First, you have to know the idea right here. Okay, maybe let us consider this. If the limit x approach 2 of f of x equal to 4, is this imply f of 2 equal to 4? Or is it imply f of x equal to 4? So to this here, then you have to understand that this one right here is you may have a conditions, okay, that the function is not a constant function. It could be a curve, okay? No. So therefore, again, f of x equal to 4 is a constant function. It might, but most of the time it's not. So therefore, f of x is not always equal to 4, okay? And then most of the time it's not equal to 4. Then the second situation is you may have the situation that f of 2 is undefined, right? Because in order to make the limit exceed, you just need to show that from the left and from the right, right? The output that we have is approach to the output equal to 4. Okay? So it may be open. So therefore, in this case, again, this is not true. Okay. So therefore, when we work it out this problem, if you write it this way, you replace f of x with 4, and then you replace g of x with -2. Okay. If you write it this way, then now you know that it is not true at all. Okay, so you cannot do it this way. So the right way to do this problem right here is to be this way. So first of all, I would like to use the property number 1 to actually to separate this into the sum of two limits. Then I will use the property number 3 to help me to take care of this now. So I have the limit x approach 2 of f of x plus 5 times the limit x approach 2 of g of x. Okay. Then now this is equal to 4. We add 5 times this right here is equal to -2. Okay. So then my answer will be 4 minus 10. So it is equal to -16. Okay. So this is the right way to work on this type of problem. Okay. So right now, maybe you could pause the video and then work it out the rest of the problem then. Okay. And now let us look at the solution to the B So in this case right here, we could actually take the limit x approach 2 of g of x, and then the whole thing raised to the power of 3. Then it is equal to -2 raised to the power of 3. So it is equal to -8. To see, we could take the square root of the limit x approach 2 of f of x. Then it is the square root of 4. So then now my answer will be 2 then. Then d is equal to the limit x approach to 3 times f of x divided by limit x approach to of g of x. Then it will equal to 3 times the limit x approach to of f of x divided by limit x approach to of g of x. And the answer 3 times 4 divided by -2. My answer will be -6. Okay. So this is how we use the limit law to help us to evaluate the limits then. Then now, let us talk about if we take the limit of polynomial functions and also rational functions. Then it's known as direct substitution property then. Okay. So we assume that P and Q, they are polynomials, and A is a constant. So then in this case right here, if we take the limit x approach A of P of x, the answer that we have will be P of A. Now you have to understand that to any polynomial functions, basically the function is continuous and smooth, right? So then when you input A right here, then your output is always P of A. Okay? So therefore, if you take the limit, okay, opposing from the left and from the right, see, to A, then the output is always go to P of A. So this is the idea. Okay. So if you have a rational functions, okay, same thing, you will see that what happened to all the rational functions. So then, even though sometimes you may have vertical asymptotes, right? But in this case right here, in order to get the vertical asymptote, it will be when Q of A equal to 0. Okay. So therefore, again, in this case, as long as A is within the domain of the function f, then your output is always, you could use the direct substitution to work it out the problem. It will be P of A divided by Q of A then. Okay, so then let's see how we actually work it out the problem. Okay, again, you could pause the video and then work it out, okay, before you review the solution then. Okay, to A, this is a constant. So in this case, my answer will be 3. Okay, again, the idea is you have the graph y equal to 3. Okay, no matter what input that you put in, then your output is always equal to 3. Okay. Then to this one is y equal to x. So if the input is 20, then of course my output is 20 then, right? Then now to this one, we could use direct substitution because this is a polynomial functions. So will have 4 times 2 squared. So it will be 16. And again, this is a polynomial function, so we could use direct substitutions. I have 5 times 3 raised to the power 3 minus 3 times 3 squared plus 3 minus 6. Direct substitutions. Okay. Then I have 5 times 27 minus 27 and plus 3 minus 6. Okay. And now this one, we have 4 times 27. Okay. And then we have it plus 3 and minus 6 is negative 3. So therefore, in this case, it will be 105. And the last one is we can use direct substitution. So I will have negative 5 plus 2 divided by negative 5. So I have negative 3 over negative 5. So my answer will be 3 over 5 then. However, not all limits can be evaluated by direct substitutions. Okay. Then let us look at the following example then. Okay. So when we try to evaluate the limits of the intermediate form, okay, so what is this form right here? Is when we take the limit x approach a of f of x over g of x, where the limit x approach a of f of x equal to 0, and the limit x approach a of g of x also equal to 0. So therefore, in this case, the form that we have it will be 0 divided by 0 then. Okay. So in this case, if we have 0 divided by 0, then one thing about this is we know that when we have it divided by 0, then again, the result that we have most of the time is undefined, but this is really special. If we have a 0 divided by 0, then what is going on? Okay. So then now let us look at the following example to see. Okay. So my question is x squared minus 1 divided by x minus 1 is it equal to x plus 1? Okay. Okay. To this idea right here, you will see that x squared minus 1, basically it will be x minus 1 times x plus 1. So then to the left-hand side, this one and this one cancel, right? As our instructor told us, right? Before calculus, then my answer is x plus 1, okay? Then we simplify it. So then my question is this x plus 1 equal to this x plus 1? I hope that your answer is no, okay? Then why they are not? Okay. So then let us look at this. The one on the left-hand side, to this one, x squared minus 1 over x minus 1, okay? What is the domain? The domain is actually all real number except x equal to 1. Because again, when x equal to 1, the whole thing is undefined, right? Because it's 0, okay? Okay, then now what happened to x plus 1 now? Okay, x plus 1 is polynomial functions, so the domain will be all real numbers, okay? Even though if x equal to 1, then your answer is 2. So therefore, in this case, they are not the same then. Okay, so I could say that, oh, it's no. Okay. However, when we try to evaluate the limits, okay. Now again, remember when we try to maybe go back to what we did before, right? When we try to graph this function right here, basically this graph function, the function will look like x plus 1, except when x equal to 1. So in this case right here, you will see that, okay, if you look at the graph, so the graph will look like this, okay? Except when x is equal to 1, what happened? We have an open right here, okay? Then if this is the case, you will see that what happened? Wow, the limit exceed, and the limit must be equal to this number right here, right? Okay. Then let's see what is this number. As we mentioned, the function, this one right here, is look like x plus 1. So therefore, to this one, the number must be 2 then, right? So therefore, my answer to this one right here, it will be equal to 2. Okay. However, if whenever time I find the limit, I need to graph it, then sometimes it's really trouble, right? Okay. So then, is there a way that we could do it algebraically then? Okay. So let's see. We start with the limit x approach 1 of x squared minus 1 over x minus 1. Okay. And then now, what I would like to do, I would like to factor the numerator. Okay. And then you will see that just like what we did before, we cancel this. Okay. And now, after we cancel, what do we have left? Okay. We have x plus 1 left. Then now, we could use direct substitution to work it out the problem. Okay. Wow. And again, as I expect, my answer is equal to 2. Okay. So from this example right here, we find that if we have it in determinant form, that means there must be one factor, okay, that make numerator and denominator go to 0. We just need to find out that factor, okay, and then factor it out and then simplify, okay, okay. And when we try to find a factor, basically the problem, this one give me the hints, okay. If I have x approach 1, then make both top numerator and denominator equal to 0. That means in this case right here, x minus 1 must be one of the factor then. Okay. Keep that in mind, okay? Okay. So then now, let us try to see if we could actually work on our first problem then. Okay. Again, I would like you to pause the video. Try to see if you could factor out the numerator and denominator, and then work it out the problem then. Then let's see how we work it out this problem. Now, to me, most of the time, when I work with this type of problem, I would like to use direct substitution to see if we have it in determinant form. So I have 16 minus 16 divided by 12 of 16 minus 12 minus 4. Okay, again, we get it 0 over 0. So it is in determinant form. So then in this case, this one give me the idea that x minus 4 must be one of the factor then. right? Okay, so let's see if this is the case. To the numerator, we have a common factor, x. So I could take out the x. So I have x minus 4. And then to the denominator, we have x squared minus 3x minus 4. Then in this case, I know that one of the factor must be x minus 4. Okay. And then to this one, it will be x. And then now I need to work with 1. So I need to have plus then. Okay. Okay. Then now we could cancel these two right here. Yes, leave me the limit x opposed 4 of x over x plus 1. Then now direct substitutions. So my answer is 4 over 5 then. Okay. Okay. So this is actually one way to actually to solve the limit if we have it in determined form. Okay. And then the second way to do this problem here is we could expand it out and then simplify. Okay. Okay. So then to this one right here, again, when we work with direct substitution, right? So I have 2 plus 0 raised to the power 3 minus 8 divided by 0. Then, of course, I find that it is 0 over 0 in determinant form. Then now, I would like to expand it out, okay? If you remember that a plus b to the power 3, it will be a to the power 3 plus 3a squared b plus 3ab squared plus b to the power 3. Then you could actually use it to work it out the problem, okay? Again, if you don't remember, then what we could do is you could have a plus b to the power 3, then you could write it as a plus b to the square, then times a plus b, right? Okay. And factor it out, and eventually you will get the same result here, okay? Okay. Then we just work with the problem then. Okay. So then I will have 2 to the power 3. This is a, and then this is b, okay? So plus 3 times a squared b plus 3 times a b squared, right? And then plus b to the power 3, okay? So which is h to the power 3 minus 8 divided by h then. Okay. Then now you will see that 2 to the power 3 and 8, they cancel. Right? And now I will have 12h plus 6h squared plus h to the power 3 divided by h. And now you could take out the h, then I have 12 plus 6h plus h squared. Then we have these two cancel here. Then work with direct substitutions. I will have 12 plus 6 times 0 plus 0 squared. Then, of course, my answer will be 12 then. Okay. So this is another technique. If we have 0 divided by 0, then we could actually expand it out and simplify. Okay. Okay. Then now, the next one, let's check it. Okay. So again, I have square root of 9 minus 3 over 9 minus 9, direct substitutions. So I have 3 minus 3 divided by 0. So I have 0 over 0. Okay. Okay. So right now, when we have the expression that contains the square root, okay, two terms like this, then we need to work with rationalizing. Okay. It depends on the root is in the denominator or numerator. If it's in the numerator, then we rationalizing the numerator then. So what does this mean by rationalizing, or how do we do this? Then you have to remember one thing is A minus B times A plus B, the conjugate pair. Then in this case, the result that I have, again, it will be A squared minus AB plus AB plus B squared. Okay, oh, minus B squared. Okay, like that. Then you will see that this one and this one cancel. The result that we have will be A squared minus B squared. Okay. So this is actually the idea about working, that's mean work with the conjugate pair. So in this case, what I need to do is actually I would like to, again, look at that's mean look at the expression that I have. If it is contain the square root, okay, so this is the one that actually need to work with the conjugate pair. Okay, so I'm going to multiply top and bottom by square root of x plus 3 over square root of x plus 3. Okay. Now remember, when you multiply root 3 plus square root of x plus 3 divided by square root of x plus 3 is actually as you multiply 1. So it will not affect the values of this expression at all. Okay, so then this is okay to work with this then. Then now I will have the first term square minus the second term square divided by x minus 9 and then root x plus 3. Okay. And now we will have x minus 9 and x minus 9 square root of x plus 3. Okay. Again, you will see that if you have x approach to 9, when you take the limit, give you indeterminate form, then x minus 9 will be one of the factors. Okay, this is exactly what happened here. Then I will have the limit x approach 9 of 1 over square root of x plus 3. And then now I put down 1 over square root of 9 plus 3. So it will be 1 over 3 plus 3. So the answer will be 1 over 6. Now, one thing that I would like you to pay attention or to note, okay? Do you see that I keep writing the limit, okay, until I work with the direct substitutions? So this is exactly what you need to do on the test, okay? Keep writing the limit symbol or notations until you work with the direct substitutions, okay? Then you don't need to put the limit notation then. Okay? Then D will be really similar to C, okay? So in this case, again, what you would like to do is you need to work with the conjugate pair, okay? So the idea is you multiply top and bottom by square root of 16 plus h plus 4 divided by square root of 16 plus h plus 4, okay? Now, one thing about the conjugate pair, of this one right here is not square root of 16 minus h plus 4. Okay. Now, some of the students confused about conjugate pair is when they thought that when you see positive, you change to negative. When you see negative, you change to positive. It's not. It's actually you look at to this one right here, you have two terms. This is my first term. This is my second term. So therefore, in this case, you need to just have this one. Okay, just change this one to plus. Okay. Okay. If this is the case, then let's see how we actually work it out the problem. Then I will have the limit h oppose 0 of 16 plus h. This one square root of this, and then square minus 4 square divided by h square root of 16 plus h plus 4. And you will see that this one right here basically is 16 plus h minus 16 all over h and square root of 16 plus h plus 4, right? And then now we will have 16 minus 16 equal to 0. So I have h left. And of course, we could cancel this. So I have 1 over square root of 16 plus h plus 4. Then now, direct substitutions. 1 over square root of 16 plus 0 plus 4. So my answer will be 1/8 then. So now, let's see if we have a piecewise functions. Then how do we actually work with the limits? Okay. Okay. So to this one right here, when we have a piecewise functions, then we are going to work with the one side limits then. Okay. So one thing about this is if you have a piecewise function, we need to work with the subdomain, right? So in this case, the subdomain is actually is like this. So I have x is -5, okay? It's less than this. And then we have -5 and 5. And then we have the third one right here is actually x is greater than or equal to 5, right? Okay. Then now, how do we actually work it out, this problem? Then first of all, you have to understand that when you have x is less than -5, okay? Then the function that you have is f of x equal to 0. When x is between -5 and 5, the function that you have is a square root of 25 minus x squared. Okay. So when x is greater than 5, then of course the function that you have, again, you're going to work with 3x. Okay. This is kind of like the idea. Okay. So then now, let us look at A then. Okay. So to this A right here, we look at x oppose -5. Okay. from the left. X approach -5 from the left. Okay. Then in this case right here, you will see that what happened to the functions. The function is we need to work with f of x equal to 0. Okay. So then of course in this case, when I evaluate, my answer must be 0 then. Okay. Then let us look at B. B is actually the limit x approach -5 from the right. Okay. If you look at the graph from the right, it's actually look like this way. Okay, approach -5 from the right. And then to this one right here, we are using the square root of 25 minus x squared. So I'm going to replace f of x with square root of 25 minus x squared then. Then now, direct substitution. So I will have square root of 25 minus x is -5. Okay, so therefore in this case right here, I will have 25 minus 25. So it is equal to 0. Okay. Then now, from the left equal to 0, from the right equal to 0. Of course, right now my limit exceeds, and my limit must be equal to 0 then. Okay. Okay, so now try to see if you could actually work with D, E, and F now, right? Okay. Okay. Then now, when I work with the limit x approach 5, okay, so right now we look at 5 now. Okay. From the left to 5, we work with this function. So now I have the limit x approach 5 from the left. The function is I'm going to replace the f of x with 25 minus x squared then. Then of course, direct substitution. So I will have 25 minus 5 squared. Then of course, the answer that I have is equal to 0. Okay. Okay. So now the limit x approach to 5 from the right, okay, from the right. Ooh, I need to work with the f of x is 3x now. Okay. Then now I will have the limit x approach to 5 from the right. Then the function is 3x. Okay. Then of course, if we use direct substitutions, then it will be 3 times 5, which is 15 then. Okay. And now from the left is 0, from the right is 15, then now to this limit will be does not exceed then. Okay. Okay, now again on the test, if I give you a piecewise functions, what you need to do, you will see that what you need to do is basically you are going to replace the function f of x with the actual function that you're using to evaluate. Okay. Then remember, when I check it, that's mean when you work on the problem, make sure that you follow this. If you have a piecewise functions, when you work with the f of x, make sure that you work with the function is from the left and from the right. Okay, just like what we did here. Okay. And now let's see how we actually work it out. The next problem then. So we would like to find a constant. So in this case, probably they're looking for b then. Suppose that f of x equal to 3x plus b if x is less than or equal to 2. and x minus 2 if x is greater than 2. Okay, so right now I have a piecewise functions. This is 2 right here is when x is less than or equal to 2, or maybe just less than, okay, is 3x plus b. When x is greater than 2, then we work with x minus 2, okay? Okay, and opposed to this one right here, it will be x equal to 2 then, right? When x equal to 2. So now let us look at the problem. Determine the values of the constant b for which the limit exceeds. Okay, and we would like to state the limit if possible. Okay, now this is actually give us a hint if limit x opposed to of f of x exceed. Okay. Imply that the limit x opposed to from the left of f of x equal to limit x opposed to from the right of f of x. Okay? The one side limit telling us this. Okay. Then now the problem is easier to work it out now. So the limit x opposed to from the left, again, what is the f function that we have here? It will be 3x plus b, which is equal to, so limit x opposed to from the right, okay, of, again, to this one, x opposed to from the right is x minus 2, okay? So then now, work with the direct substitution. So I will have 3 times 2 plus b is equal to 2 minus 2. So therefore, in this case, I have 6 plus b equal to 0. So b is equal to -6 then. Okay. And now, we need to find the limit now. The limit x opposed to from the left, it is 3x minus 6. Okay. So you will see that is 3 times 2 minus 6, which is 0. And limit x opposed to from the right is x minus 2, which is 2 minus 2 also equal to 0. So based on these two right here, we could make the decision that the limit x opposed to of f of x is equal to 0 then. Okay. So here, you will see that when I work it out the problems, when I find the limits, there's no superscript here, no positive or negative here, right? Because this is the result of the limit then. We find out from the left equal to 0, from the right equal to 0, then the limit exceeds, and the limit of f of x has x opposed to must be 0 then. Okay, so now then let us work with the last two problems. Now the last two problem is actually related to the absolute value. Okay. Now, one thing that you have to remember, the absolute value of x plus 6 not equal to just x plus 6. Okay, they are not equal. So how do we actually take care of this problem then? Okay. So we go back to, or that means the basic is we work with the direct substitutions. So I will have 2 times negative 6 plus 12 divided by negative 6 plus 6. Okay. Then in this case, you will see that this is negative 12. So I have 0 here and then also 0. So I have 0 divided by 0. So again, I cannot work with the direct substitutions. Then how do we actually work it out the problems then? So to this problem, we need to see how we take care of this absolute value of x plus 6 then. Okay. Okay. Then one thing about this is we know that absolute value of x is equal to negative x if x is less than 0, and then equal to positive x if x is greater than or equal to 0. Okay. Again, if you remember the graph of the absolute value, right? Okay. So to this side, y is equal to negative x. And then to this side, y is equal to x, right? Okay. So then this actually is something that we know, okay? And then now, what I'm going to do is, I'm going to work with this now, okay? What we are going to do is, we would like to replace, okay, again, we would like to replace x with x plus 6. So then now, I replace all the x with x plus 6. If x plus 6 is less than 0, if x plus 6 is greater than or equal to 0. Okay. Then now, if this is the case, we will be able to get the result if x is less than negative 6 and equal to x plus 6 if x is greater than or equal to negative 6 then. Okay. Okay. And now let us work with this problem. Okay. So when now, what I need to do is I need to separate into two limits. The first limit is has x approach negative 6 from the left side. Okay. Okay. So then now, if we look at the graph of this one right here, basically now I actually have this negative 6 right here. Okay. Then to this one, when x is less than negative 6, the function that I have is actually is negative x plus 6. Okay. And to this side right here, it will be x plus 6. Okay. Okay. So now, if I have x opposed to negative 6 from the left-hand side, opposed to negative from the left, then I'm going to work with the green line right here, right? Which is this one. So I'm going to replace the absolute value of x plus 6 with negative x plus 6. Okay. So once I replace this absolute value of x plus 6 with negative x plus 6, then now I will be able to evaluate the limits. Okay. Then you will see that this one and this one cancel, so my answer will be negative 2. Okay. And now, if we take the limit x opposed to negative 6 from the right, okay, then again, I have 2x plus 12 over. Okay. Now, from the right, we need to work with, okay, now this part right here, right? That means we need to work with this, okay? So then, in this case, I will have the function will be x plus 6 now. Okay. And of course, on the right. So 2x plus 6 divided by x plus 6. Okay. Then this one and this one cancel. My answer is 2. From the left is -2. From the right is 2. So now we will say that the limit x approach -6, 2x plus 12 divided by absolute value x plus 6 does not exceed then. Okay. Okay, so now let's see if you could use this idea right here to help you to work with B. Okay. So to B, again, I'm going to start with the absolute value of x. We write down this definition first, okay? Always. Okay. Then now, let us look at the functions. Okay. So we are going to work with the limit x approach to -2. Okay. Okay. Then now, let's take a look. -2 is here. Okay. From the left and from the right, we are working with the same function, isn't it? This is the same function. So therefore, in this case right here, we don't need to work it out like the previous example that we need to separate them then. Because again, the reason that why we separate this from the left and from the right, because from the left and from the right, they are different functions. However, to this problem here, from the left and from the right, they are the same functions. Okay. So, and the absolute value of x is -x. Okay. So in this case, then now I will have the limit x approach -2 of 2 plus x over 2 plus x. Okay. Then now they cancel it, and then it's equal to 1. Then my answer will be 1 then. Okay. So there is a way to check your answer. Okay. That in order to work with the answer, we could actually use a graphing calculator to help us to graph the functions. Okay. And then try to determine it from the graph. Okay. So then now let's bring out our calculator, and then we are going to work with this problem, right? Okay. So now let's go to y equal to, let me create a function first. Okay. So to this one, I would like to input the function is 2x plus 12 divided by the absolute value. So we could get to math and then find the absolute value, which is ABS. Okay, this one. So put enter and x plus 6. Okay, and then now let's us try to graph this function right here. Okay. Okay. Now, do you see that we would like to evaluate the limit as x approach -6? So from the left, we have this is -2. And then from the right, we have it equal to 2. So therefore, the limit does not exist here. Okay. Okay, so now of course on the test, if I have this type of problem, I will, that means again, in order to get a full credit, you need to show, you need to show the, again, to have like how we define the absolute value first, and then how you use the absolute value to help you to evaluate the limits. Okay. Okay, so that's it for this lectures of section 2.3. And this section right here basically is introduced, have like the limit law, and also how do we actually use a limit law or to evaluate the limits. And if we have it in determined form, then what we need to do. Okay. So thank you.